Good morning, class. We are looking at College Algebra Chapter 2, Equations and Inequalities. Section 2.7, Linear Inequalities and Absolute Value Inequalities. So we've looked at the rectangular coordinate systems, linear equations, models and applications, complex numbers, quadratic equations, other types of equations, and now linear inequalities and absolute value inequalities. The objectives. We want to use interval notation, use properties of inequality, solve inequalities in one variable algebraically, solve absolute value inequalities. Again, reminding everybody of the distance formula, the equal square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus 1 quantity squared, and the midpoint is x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. Those are the coordinates for the midpoint. Proportion is in the form of A over B equals CD, and this is the cross product, AD equals BC. Rise over run, that's the slope. Various lines, standard form, AX plus BY equals C. Slope intercept form, Y equals MX plus Y equals MX plus B. Point slope, Y minus Y1 equals M times X minus X of 1. Vertical lines, X equals A is the equation. Slope is undefined with the intercept A0. Horizontal line, Y equals B, M equals 0, intercepted at 0, B. Parallel lines equal slopes, perpendicular lines, slopes that are negative reciprocal of each other, and complex numbers are in the form of A plus BI. Their conjugate is A minus BI, where I is square root of negative 1. Square root of negative n is I squared of n. I is square root of negative 1. I squared is negative 1. I cubed is negative I, and I to the power of 4 equals 1. There are some identities we should know, such as A plus B squared, A minus B squared, A plus B times A minus B. A quadratic equation is in the form of AX squared plus BX plus C equal to 0, where A can't be 0. And the methodology to solve would be factoring, square root principle, completing the square, the quadratic formula. And this is extremely important to remember. X is minus B plus minus the square root of B squared minus 4AC over 2A, with B squared minus 4AC known as the discriminant. When it's positive, gives us two solutions, 0, 1, and when it's negative, it gives us no solutions. That means no real solutions or two complex solutions. Of course, exponential rules we should be comfortable with. And now we are looking at other types of equations in order to solve something like a radical, or for that matter, absolute value. Number one, you are going to isolate the radical or the absolute value. Raise each side to an appropriate power, combine like terms, and repeat the steps if need be, and solve. Always check with the original equation. As far as the absolute value principles are concerned, remember absolute value by definition is distance from 0. So for any positive number k and any algebraic expression x, if absolute value of x equals k, that means x is plus minus k. If absolute value of x equals to 0, the only solution x equals 0. And if absolute value of x equals negative k, there is no solution. Now, 2.7, linear inequalities and absolute value inequalities. An inequality is a mathematical statement containing one or more inequality sign, less than, greater than, less than or equal, greater than or equal. A linear inequality in one variable is an inequality that can be written in the form ax plus b less than c, or less than or equal to c, or greater than c, or greater than or equal to c, where a, b, and c are real numbers and a can't be 0. A is not equal to 0. Any value for a variable that makes an inequality true is called a solution. The set of all solutions is called the solution set. When all solutions of an inequality are found, we say that we have solved the inequality. Interval notation, inequality notation, graph. So let's look at an open interval of a to b, x such that x is between a and b. And on a number line, we cover everything from a to b, and the endpoints a, b are not included using parentheses. When we use brackets, it's a closed interval, meaning the endpoints are included, meaning x such that a is less than or equal to x, less than or equal to b. So brackets mean the endpoints a, b are also included. Half open interval. Sometimes they just call it half open, half closed. In this case, on the left side, we have a bracket. On the right side, we have a parenthesis. So a is included, b is not included. So x such that a is less than or equal to x, less than b. So in the case of a graph, a is included and b is not. Sometimes they use a solid point for bracket and a hole for parentheses. Either way is fine. Now, in this case, A was included. In this case, B is included. And generally speaking, they call it half open, half closed. So the interval of A to B, A takes the parentheses, B takes the bracket. A is less than X, less than or equal to B. And as far as the graph is concerned, A is not included, B is. From A to infinity, that means X is greater than A, and we have bracket by A, and it goes all the way to infinity. Infinity as well as negative infinity are concepts. They never get brackets, but rather parentheses. Okay, that part is the difference. The endpoint A is included here. In this case, is not. So parentheses A, comma, infinity, X larger than A, and A is not included, therefore. Interval of minus infinity to A, close bracket, X is less than or equal to A. Anything to the left of A, including A, as far as the graph is concerned. The interval of minus infinity to A with parentheses, that means X is less than A. That means A itself is not included. We also have the interval of negative to positive infinity. X is any real number, and sometimes we just represent it with R. That has the same meaning, everybody. A closed circle, the end point is included in the answer. So instead of bracket, we can use a solid point, a closed circle. Symbols such as greater than and less than. When we graph them, we use closed circle. An open circle, the endpoint is not included in the answer. Symbols such as greater than and less than. Write each inequality using interval notation and graph each inequality. So x is between -2 and 0. -2 is not included. 0 is included. So we use parentheses next to -2, bracket next to 0. On a number line, we cover everything from -2 to 0. -2 itself is not included. 0 is included. X is less than 3, so the interval notation from -infinity to 3. On a graph, we go from 3 to -infinity on the left side, and 3 is not included. X is between -1.5 and 3, so we put parentheses for both of them. So -1.5 to 3. And as far as the number line is concerned, we shade the region between the two numbers and we use parentheses. The thing I want to add, we could, but don't mix them up. We could use, in this case, for example, solid point. In this case is a hole, okay? Is a hole here, over here is a, but don't mix them up. Write each interval notation as an inequality and graph each inequality. By the way, speaking of inequality, you really can use any variable. Normally we use x, but if you use any other variable, will do the job. So this means x is between -4 and 2, and both sides, they have the equality. So -4 less than or equal to x less than or equal to 2. Graphing, just put it on a number line from -4 to 2, and the endpoints are included using either brackets or solid points. This one, from 3/4, which is a little bit less than 1, to infinity. So x is larger than 3/4. X is larger than 3/4. And on a number line, you locate the 3/4. So somewhere between 0 and 1 or closer to 1. And you use either a whole or parentheses and all the way to infinity. 0 and 4, that means x is between 0 and 4. X is between 0 and 4. And you locate 0, locate 4, everything in between, the endpoints 0 and 4 are not included. Properties used to solve inequalities. In short, we use the same type of properties that we used in solving equalities. There's only one slight difference, and that would be when you multiply or divide by a negative number, things change. So you want to be careful with that. Other than that, everything is the same. So first and foremost, you are going to move this changes to +7. We get 5x larger than or equal to -10. Divide both sides by +5, and that's the key, +5. X is larger than or equal to -2. So that means on a number line, we locate -2 and all the way to the right. Now you can use a solid point or bracket. The interval format from bracket -2 to infinity, and we're done. So it makes perfect sense. Let's discuss these properties. For all real numbers, A, B, and C, the addition property indicates if A is larger than B, then A plus C is larger than B plus C, meaning add anything you want to both sides. Remember, subtraction is a form of addition. So if I have this inequality, I can add or subtract anything I want, and everything, the sign, inequality sign remains the same. If it's greater than, remains. If it's less than, and so on. So for the addition property, do add or subtract anything you want from both sides. What about multiplication property? Well, if A is positive, larger than B, and C is positive, you can multiply by C and nothing changes. Again, it remains the same. By the way, division is a form of multiplication, which means you can divide or multiply by a positive number. And that's the key, everybody. However, if C is negative, the sign will change, will flip over. That's the thing you want to be careful of. A simple example to make some sense out of this. We know 2 is less than 3. If I multiply both sides by 4, multiply by 4, I get 8 less than 12. If I multiply both sides by negative 4, I'm talking about both sides of the original inequality, I get minus 8 on the left, I get minus 12 on the right. Is minus 8 less than negative 12? No, it flips over. It's larger than. That's what's happening. And a simple example can show you how it works. So try to avoid dividing and multiplying by negative in order not to make a mistake. Here's the inequality we want to solve. X minus 4 over 3 plus 3 equals x over less than or equal to x over 8. When fractions are involved, whether you're dealing with equality or inequality, makes no difference. The best course of action is to get rid of the fractions by multiplying both sides by LCD. As you can see on the left side, we have the denominator 3, on the right we have 8, and their LCD is 24. And since 24 is a positive number, we're going to multiply both sides and the sign remains unchanged. So when we multiply 24 by the first piece, this number 3 goes away and becomes 8 times x minus 4. And then when we multiply 24 by 3, we get 72. And this one, 8 and 24 cancel each other. The right side becomes 3. So I want to make sure we understand what's going on here. So this one cancels out the 3, gives us 8. These two result in 72, 24, and 8. They result in 3. All right. No more denominators. Let's distribute number 8. We get 8x minus 32. Minus 32 and positive 72, they add up to 40. We move things around. We get 5x equals negative 40. Now we divide both sides by 5. and x is less than or equal to -8. So we are dividing by 5. They just solve for the inequality. They asked to solve for the inequality. They then asked for the interval notation or the graph. But a quick answer to those, this is the inequality and you're done. But if we were to write, for example, the interval notation from -infinity to -8, -8 is included. If we were to go with the graph, we would locate -8 and shade everything to the left of it. All right, we want to solve this inequality, so that means we have to distribute. Six p minus 10 plus 9, that's the left side. 8p plus 8 minus 2p plus 6, the right side. On the left side, we have 6p minus 1 because -10 and 9, they add up. On the right side, 8p and minus 2p, they add up to 6p. Eight and 6, they add up to 14. Now, you can move things around or just write. I mean, I'll show you. You move things around. Okay, you move the, for example, 6p, and you end up with that. Or I would have just dropped this and come up with this. Now, -1 less than or equal to 14 is either a true or false statement. Because it's a true statement, that means this inequality will always work regardless of the choice for p. Therefore, the answer is all real numbers. You can see on the graph of a number line, that means it continues indefinitely on both sides. Negative to positive infinity, this is interval notation, or as I mentioned, you can put R. That means all real numbers. Of course, when they ask you to solve, you answer accordingly. So solving an equality would be this. This would be the interval notation. This would be graphing on a number line. Compound inequalities. A compound inequality is formed by joining two inequalities with the word and or. So examples of compound inequalities would be 3 is less than x and x is less than 5. Now, what it really means, whenever you see the and, which means intersection of events, which means common, it only works if this variable x can be sandwiched between the two numbers. And I hope you recognize this is the same as x being between 3 and 5. Because on the one hand, x is larger than 3. On the other hand, x is less than 5, again, with the and statement. If you can make a sandwich like this, x is squeezed between 3 and 5, that works. 5x minus 3 is less than 7, or minus x plus 3 is less than minus 5. That's an or statement, the union of events. Intersection, union, we'll discuss that with more details in a moment. And of course, in an or statement, you solve each inequality and you come up with the answer. These are examples of compound inequalities. When you have a case like this, x is less than 2x plus 1 and 2x plus 1 less than 7. Notice this. Is the same as this one. And this only works if we can sandwich between the two numbers. And in this case, 2x plus 1 is larger than 3 on the one hand. On the other hand, it's less than 7. And this is equivalent to that. So with the AND statement, we should be able to come up with an equivalent format. So we said AND represents what's in common or intersection. Intersection of sets and conjunction of sentences. The intersection or conjunction of two sets A and B is the set of all elements that are common to both A and B. We denote the intersection of sets A and B as A intersection. We look at this sign, it almost looks like an N. So here's the A set, here's the B set, and this is what's in common, A intersection B. This is a Venn diagram. Here's an example. We want to find the intersection of the two. So one is A, B, C, D, E, F, G, and we want to find the intersection of this set with this set, intersection with the set A, E, I, O, U. So that's I want to make sure that we're comfortable with the concept, everybody. So Venn diagram. All right, let's see what's in common. A, yeah, okay, A is in common. B, C, D, I don't find them here. E, okay, we have it here. So let's do that. So A, E, then I see F and G, then I see something else, I, O, U. Therefore, just A and E. Now, of course, we have the concept of a union that means everything and don't repeat them, okay? In which case becomes all of the first one and then I, O, U. That's the concept of the union. To solve compound inequalities involving AND. When two or more sentences are joined by the word AND intersection to make a compound sentence, the new sentence is called a conjunction of the sentences. The solution of a compound inequality using the word AND is all the numbers that make both parts of the inequality true. This is the intersection of the solution sets of the two inequalities. And this was an example that we discussed. And let's see how that thing works. X is larger than 3 and X is less than 5. So if you go with X larger than 3, so from 3 to infinity, x is less than 5 from 5 to negative infinity, and what's in common? Anything between 3 and 5. So a graph can indicate what's in common. Needless to say, we do not have the equality, therefore the endpoints take the whole, okay? And so the solution set is the intersection of the two inequalities. And of course, notice, and that is extremely important, the two can be put into this format of x is sandwiched between 3 and 5. And if we can do that, we can easily see the answer. So the word and corresponds to intersection and to the symbol, which looks like an and. This is the intersection symbol. Intersection symbol. Solve and graph 2x plus 1 is larger than or equal to negative 3 and 3x is less than 12. Well, we're going to start solving by moving things around. For example, here, I move it here. Then I'm going to divide by positive 2. I'm going to divide this one by positive 3. And it results in this case, x is larger than or equal to negative 2. And in this case, x less than 4. If we were to look at the graph, x is less than 4 for this one goes to negative infinity, larger than negative 2 goes to positive infinity, and this is the piece is in common. One easy way to understand this class is this. Notice this one is the same as x being sandwiched between negative 2 and 4. See, x is less than 4, so 4 is on this side. And x is greater than or negative 2, negative 2 is on this side. If you can go from this format to this format, it makes it much easier to graph this. And needless to say, if they ask for the interval notation, bracket negative 2, comma 4, parentheses negative 2 is included, 4 is not. Sometimes there is no way to solve both parts of a conjunction or intersection at once. So when we look at this Venn diagram, A and B, they have nothing in common. So in this situation, A and B are said to be disjoint. They have nothing in common. A intersection B equals phi I. I'm telling this is phi, which is representing an empty set. It's a Greek letter phi, which represents an empty set in set theory. It is not 0. So we want to solve this. 5 plus x is larger than 10, and x minus 4 is less than negative 3. So we just move things around. That's all. So all we have to do subtract 5 from both sides. In this case, we add 4 to both sides. So what happens? X is larger than 5 and X is less than 1. Can you sandwich between the two numbers? How could a number be larger than 5 and at the same time less than 1? We don't have a solution. Since no number is greater than 5 and less than 1, the solution set is the empty set. And either you represent it, if you were to represent it with a number line, nothing is shaded, or you could just go with that, or just write down no solutions. That's extremely important to understand the concept. Unions of sets and disjunctions of sentences. The union of two sets A and B is the collection of elements belonging to A and slash or B. We denote the union of sets A and B by A union B. Looks like a U. So here's the A set, here's the B set. Everything put together is A union B. When two or more sentences are joined by the word or to make a compound sentence, the new sentence is called disjunction of the sentences. Now, we want to find the union of these two sets, A, B, C, D, E, and A, E, I, O, U. So basically, you start writing the first one, all of it. And then A, so it's in here, don't repeat that. E is in here, don't repeat that. But I don't see I, O, U, just add those three. So again, first we write all of those, and then we write whatever is in there that you find it in here. You don't find it in here. So that's how it's done. Solve compound inequalities involving or. The solution to a compound inequality using the word or is all the numbers that make either of the inequality is a true statement. This is the union of the solution sets of the two inequalities. So in this example, we want to solve one graph 2x plus 1 is larger than or equal to 3, or 3x is less than minus 3. Well, we start moving things around, meaning subtract 1 from both sides. Divide both sides by 2 for the first case, 3 for the second case. The first one becomes x larger than or equal to 1. The next one becomes x less than negative 1. So if we have a number line, this means locate 1 and everything to the right of it. This one means locate negative 1 and everything to the left of it. This one is included. This one, negative 1 is not. So For this one, anything to the right of 1, including 1. For this one, anything to the left of -1, not -1. So this means parentheses or a hole. This means either bracket or a solid point. Interval notation. This is -∞, comma -1, union 1 to infinity. So this pertains to the first part. This pertains to the right side. So the interval notation, -∞, comma -1, union 1 to infinity. A neighborhood HOA is planning to enclose a new playground area with fence. Cost restricts the HOA to a total of 320 feet of fencing materials. If the playground is to be 75 feet wide, what is the maximum length of the playground? So we have a playground in a shape of a rectangle. The width is supposed to be 75. We need to find L. We know we can't have more than 320 feet of fencing, and P, the parameter, is 2L plus 2W. This is the one that can't exceed this number. Okay. So 2L plus 2W less than or equal to 320 feet, and W can be replaced by 75. Which makes it 150, the product of the two. We are going to subtract it from 320, we get 170. We're going to divide by 2, and the length becomes 85 feet. So the length can have a maximum, we can have a maximum length of 85 feet. It has to be less than or equal to 85 feet. Dress sizes X in USA can be converted to dress sizes in Italy using the function f of x equals 2 times x plus 10. For what dress sizes in USA will dress sizes in Italy be between 32 and 46? So in Italy, this is what we have. And we want this one to be between these two numbers. So we want f of x between 32 and 46. Replace it with 2 times x plus 10. Distribute and simplify. Or here's a faster way, everybody. You notice we can divide both sides by 2, all three sides by 2. And that's a faster way instead of distributing. You can distribute and do it at the end, but this is a faster way. So let's get rid of the 2 because it's being multiplied here. So this becomes x plus 10, this becomes 16, this becomes 23. Move the 10, meaning we are going to say minus 10 here, minus 10 here, minus 10 everywhere, okay? And so x is somewhere between 6 and 13. That is the answer to the question. A company charges $65 plus $45 per hour for copier repair. Ben was billed no more than $150 for his copier repair. How many hours was the copier worked on? Well, how many hours? We let X, Y, Z, N, H, whatever you want to represent the number of hours. So let H represent the number of hours. You have to decide on your variable. Now, how do they charge us? A fixed cost, an initial fee, and then 45 per hour, 45 times H. And it's no more than 150, less than or equal to 150. When it says no more than 150, can it be 150? Yes, that means equality. Okay, everybody? Can it be equal? Yes. A quick recap. There is an initial fee or a fixed cost of $65, then $45 per hour. And H represents the number of hours, their product. That's how much we pay. It's less than or equal to 150. We are going to move the 65 and subtract it from 150 to get 85. Divide by 45. $85 over 45, which is 1 and 8 over 9. So H is less than or equal to 1 and 8 over 9. This is a precise answer. Okay. However, if we want to be more practical in some cases, even a fraction of an hour, they charge the whole hour. It depends on how the company charges. We are just calculating the exact value. But they're both divisible by 5, by the way. That's why we get 8 over 9. 1 and 8 over 9. I don't believe that should be any problem. Solving equations and inequalities graphically. We want to solve this. Part A, minus 2x plus 7, less than or equal to 4x plus 1. Part B, minus 2x plus 7, greater than or equal to 4x plus 1. Notice the two of them are identical with the difference in the sign. One is less than or equal, one is greater than or equal. And I wanted to show you that how they work together. Whether it's less than or equal, greater than or equal, less than or greater than, the process is the same. So for both cases, the process is the same. And we're going to go through that process, everybody. And we'll see the similarities as well as the differences. So, two things we need to do. Each side there is a line. We have to draw each line and we have to find the point of intersection. So that's the process. So find the point of intersection of two lines. And as you know, when you solve inequalities, because y's are equal, set these two equal and solve for x. And move things around. Divide, so we get 6 equals 6x, divide by 6. X becomes 1. And now If you put that into one of the original equations, for example, this one, negative 2 times 1 is minus 2 plus 7, we get 5. Now, it is extremely important that you check this with the second line. If I put x equals 1, do I get y equals 5? So it checks. So the pair is 1 comma 5. I'm assuming we can graph this easily. Okay, just to give you an idea, for the blue line, obviously 0, 7, 0, 7 is the y-intercept. And then if you set y equal to 0, 7 halves 3.5. Okay, so just for the sake of argument, let me use a blue one. For the blue one, when x is 0, y is 7. When y is 0, x is 7 halves. For the red line, when x is 0, y is 1. When y is 0, x is negative 1/4 class. If you set this one equal to 0, x is negative 1/4. Okay, so it's easy to graph, and here's the point of intersection with coordinates 1 comma 5. Now, the graph of y equals minus 2x plus 7, meaning the blue one, lies on the graph of y equals 4x plus 1. That means the red one. When x equals 1, meaning at x equals 1, the two are identical. There is a point of intersection. However, the graph of y equals minus 2x plus 7, the blue one, lies below the graph of y equals 4x plus 1, below this line, as long as x is, look at this one, x is larger than 1, meaning from here on. So one more time. The blue line is below the red line as long as x is larger than 1. That means the blue line is less than or equal to the red line. That's the meaning of it. And therefore, the solution for part A, x such that x is larger than or equal to 1, or we can say 1 to infinity. And for this one, it's the other way around. That means the rest of this, that means from negative infinity to 1. X such that x is less than or equal to 1 because of the equality, or minus infinity to 1. So this blue line is above the red line here. So for this one, see what color do I want to use? For this one, we are looking at this portion, and that's the answer. And for this one, we are looking at this portion, and that's the answer. That's as far as graphing goes. Absolute value inequalities of the form absolute value of x is less than a. If absolute value of x is less than a and a is positive, then x is sandwiched between minus a and a. So a warm-up example, the absolute value of x is less than 3, basically sandwich it between -3 and 3, according to this. Which means on a number line, anything from -3 to +3, and of course the endpoints are not included because we don't have the equality. Now, absolute value of 2x minus 3 less than 5, just like the equality, first the absolute value equality, first you want to make sure it's completely isolated before you move on. It is. Now you sandwich this between a positive and -5. Now we are going to solve this. By adding 3 to all sides. Dividing by 2 all sides. X is between -1 and 4. So this is divided by 2. And that means if you go with the number line, anywhere between -1 and 4, and the endpoints are not included because we don't have the equality. All right, we want to solve. This is example 18. We want to solve, graph the solution set, and write the solution set in both set builder and interval notation for the absolute value of x minus 3 less than 6. All right, so absolute value of x minus 3 is less than 6. We are going to sandwich that between a positive and -6. Then we are going to move the -3, meaning we're going to add to all sides +3. And therefore, x is between -3 and 9. So that's the solution. We're going to graph it on a number line. So everything from -3 to +9 is covered. You locate those. Everything from -3 to +9. And those two are not covered because of the equality. In other words, the endpoints take either whole, you put a hole here, you put a hole here, or parentheses. The set builder simply put means basically write the same thing, but in the following manner. Braces x, this line segment is read such that x is between -3 and 9. This line segment is read such that so x such that x is between -3 and 9 in braces. Finally, we want it in the interval format. from -3 to 9, both of them in parentheses. That would be the interval form. So we have different formats. We want to solve the absolute value of 3x plus 7 less than or equal to 8 and then graph it. Well, in order to do that, we are going to sandwich this between negative and positive 8. We're going to move the 7. That means we're going to add -7 to all sides. Left side becomes -15. Right side becomes 1. In the middle, we have 3x. We're going to divide everything by 3. So x is between -5 and 1/3. Both numbers are included. So if we, this is the, if they said solve, basically you're done. Okay. What is left is the graph, but I want to show you more than that. First, if you want to put it in a set builder, x such that x is between -5 and 1/3 inclusively, that means equality sign is also there. The graph is as follows. You go on a number line and you locate -5 and 1/3, everything in between, and the endpoints are also included because of the equality. Therefore, we use brackets. Interval notation, they didn't ask for it, looks like that. Absolute value inequalities of the form absolute value of x is larger than a. If absolute value of x is larger than a and a is positive, a is larger than 0, then x is either less than minus a or x is larger than a. For example, we want to solve the absolute value of 2x minus 3 larger than 9. This is a positive value. So we drop the absolute value and we say it's either less than -9 or greater than +9. This has got to do with understanding this concept. So from here to here, you drop the absolute value and you say it's less than -9 or larger than 9. So we are going to solve each case by adding 3 to both sides. Left side in both cases becomes 2x. Less than -6, 2x larger than 12, and we divide by 2, we get -3 and 6. So this one divide by 2, x is less than -3. This one, x is larger than 6. So again, it's a pretty straightforward process, everybody. So x is either less than -3 or larger than 6. So first and foremost, this would be your final answer, and that's fine. Or you may represent it in a format set builder, x such that x is less than -3 or x is larger than 6. Interval notation, this means -8 to -3 union 6 to infinity. -8 to -3 union 6 to infinity. If I were to go with a number line, and somewhere here is 0, I would locate -3 with a hole, everything to the left of it. I would locate number 6. I thought I said a hole and then. And everything to the right. What about this case? You want to isolate the absolute value. You don't need to. It's already isolated. So simply put, according to this one, drop the absolute value and say it's less than -5 or larger than 5. Move the 7. The first one becomes x less than -12 and or x is larger than -2. If they said solve it, you're done with the solution. You could write it in this format, of course, but that's the solution. On a number line, locate -2 and locate -2. To the left of -2, to the right of to the left of -12, to the right of -2 is shaded. And the endpoints are not included because we don't have the equality. A set builder notation uses the same thing here, x such that x is less than -12 or x is larger than -2. Interval notation, -infinity to -12, union -2 to infinity. The example 22, the absolute value of 4x plus 7 minus 9 larger than -12. Whether you're dealing with absolute value equality or inequality makes no difference. The first step is isolation of that. So you can't remove the absolute value until it's completely isolated. I can't emphasize this enough. So what do? You move the -9. And you make it +9, you add it to -12, you get -3. Now it's time to solve. So first step, isolation. Now the solution in this case is all real numbers. X such that X is a real number, or R. Interval notation is -infinity to +infinity. I want to make sure we understand why this is the case. We are saying absolute value, doesn't matter what's in there, is larger than a negative number. It is a true statement regardless. True statement always, again, is an absolute value always larger than a negative value? Yes. Why is that? Because absolute value is distance from 0, and the smallest value would be 0 for it. So absolute value of anything, worst case scenario is 0. So it's larger than any negative number. So all real numbers, negative infinity to infinity, we're done. So if we were to put it on a number line, it will look something like this. Therefore, if absolute value of x larger than a and a is less than 0, then the solution set will be all real numbers. Example 23, absolute value of 6x minus 8 plus 5 is less than 3. We want to solve this. And of course, the first step is isolation. You must move this, subtract it from the other side. And the right side becomes negative 2. The absolute value of 6x minus 8 or anything else is less than negative 2. Absolute value in the worst case scenario becomes 0, so this will never happen. There is no solution. The solution is the empty set or the phi. So if absolute value of x is less than a and a is less than 0, then there is no solution whatsoever. So absolute value of x is larger than a and a is less than 0, all real numbers. Absolute value of x is less than a and a is less than 0, no solutions. The last thing I want to quickly add is the following, everybody. Minus 2x less than 10. If you want to solve this, let's say this is part C. You have to divide by a negative value, negative 2. So what happens, it flips over. That's the only reason I wanted to solve this. Of course, you know how to graph it and put it in interval format. So if you're dividing by a negative value, it will flip over. That's the only thing you want to be careful of. So minus 2x less than 10. Divide by negative 2, this becomes x. Divide by negative 2 becomes minus 5. The sign will change.